All right, Evelyn. So what we learned was how to take a quadratic equation from standard form, which is ax squared plus bx plus c, and then change it into factored form. And factored form looks a little bit different. I'm sorry, not factored form, vertex form. My bad. Vertex form looks like so. Y equals a times the quantity x minus h squared plus k. Once we convert it to this form, it's very easy to find the vertex and axis of symmetry. That is the benefit of converting something into vertex form. Our vertex will be at h comma k, and I'll talk about that once we get there. And our axis of symmetry is the equation x equals h. We must always include that x equals, otherwise technically the problem's wrong. Now, the way that we convert into vertex form is by using the completing the square from 3.5b. So I'll go through the steps for this one. X squared plus 5x plus 6. Step 1, actually that's fine. Step 1 is we want to group the first two terms. Specifically, we want to group our x squared and our x term. Group terms. So in this case, I'll do it in green parentheses. That's just these first two, x squared, 5x. Really easy first step. Step 2, complete the square. This is what we did in 3.5b. Complete the square. That is where we take the b number, divide it by 2, and then square it. In this case, b is always the number next to x. So my job is to take b over 2 and then square it. However, in this problem, b is 5. So I have 5 over 2 squared. 5 divided by 2 is 2.5. And 2.5 squared is 6.25. This number is what I will be using to complete the square. And the way that we completed the square in 3.5b is we added 6.25 to one side as well as the other. However, for completing the square, we can save ourselves a step. We could add it to both sides, but eventually to get y alone, we would have to subtract it to move it onto this side. So to save ourselves a step, what we do, let me write this out first. I'm going to copy my equation, y equals x squared plus 5x. Leave yourself some room to add the number. This over. And plus 6 is up here. So again, we're going to add this number inside. Plus 6.25. I'll give myself enough room for that. Plus 6.25. And because I added it on the inside, we will always add it inside the parentheses. We are going to subtract it on the outside. So officially, the rule is the same as what it is when we use completing the square. However, just to save ourselves a step, we're going to add this number on the inside, and we subtract it from the outside. Okay, so we've completed the square. Our third step and our final step for getting factored form, sorry, I keep saying factored form, for vertex form, is to factor it out and simplify. Okay, so I have y equals, this is always a perfect square trinomial. Meaning, the two numbers that multiply to this happen to add to this. So the easiest and quickest way to do this is go ahead and put your parentheses with the squared. I see an x plus, so that's what I start off with. And you can either you can take the square root of the last number, which is kind of a pain if you don't know the square root of it, or B, you can just cut this number in half. And we see that number right here. It's 2.5. So I think that's easier. Either way, when we factor this, it factors into x plus 2.5 times x plus 2.5, or simply x plus 2.5 squared. All right, I've simplified that part. Let me simplify this part. 6 minus 6.25 is negative 0.25. And here I now have what is called vertex form. A times x minus h squared plus k. Now, to find the vertex, we need to find h and k. H, as we can see from this problem, is located inside the parentheses, but notice that there's this minus sign in front of it. What that minus sign does is it makes it so that whatever we're looking for h, we will actually see the opposite of it. So even though I see a positive 2.5 in here, I know that my vertex is h, or its x coordinate, h is negative 2.5. To find k, well, k is on the outside of vertex form. And notice there's a positive in front of it. So this one, we don't have to change the sign. We just keep it as whatever we see it as. So I see minus 0.25. That means my k coordinate, or my k value, is negative 0.25. Now the vertex of my parabola, if I were to graph it, is right here. Negative 2.5, comma, negative 1/4, or negative 0.25. And again, the vertex is the lowest point or it's the highest point, depending on whether your parabola opens up or down. To tell whether our parabola opens up or down, we look at the A value. If A is positive, it opens up because positive people smile. If it opens down, that means our A value was negative, just like negative people frown. So looking in my problem, I don't see a number up front, meaning there's a 1 there. And since it's not negative, it must be positive. My A value is positive, so I know if I were to sketch a graph, it would look something like this, and the vertex would have the coordinate negative 2.5, comma, negative 0.25. The axis of symmetry, write that further up. The axis of symmetry is simply the equation x equals h. The axis of symmetry is a line that passes through the middle of our parabola. So x equals, and again, h was negative 2.5, so my axis of symmetry is at negative 2.5. There we have it. So we get it into vertex form. Vertex form tells us, there we go. Vertex form tells us our vertex and axis of symmetry so that we can get a pretty decent sketch of our graph. Now, I didn't actually draw my coordinate grid. I believe if there are problems that want it, you will just have to fill it in on a coordinate grid. But that is the basics for this. I want to go through one more example. I'll actually make it a little bit bigger. So we can see it better. Now, the reason I want to go through this one is because it has a number in the front. It has an A value. This presents us a little bit of difficulty, or at least an extra step, the step that we in class called step 1.5. So step 1 is the same. Group your first two terms. Step 1.5, right in between steps 1 and 2, is I need to get this 2 out of here. I don't want it to be there. So I am going to factor it out of both of these terms. When you factor it out, essentially what that means is dividing both of them by 2. We're factoring out this number. When I do so, I will pull the 2 out front, and what I write in the parentheses is what I have left. So 2x squared divided by 2 becomes x squared. These cancel out. 10 divided by 2 is 5, and it was a positive, so I will keep it positive. Don't forget your x that was already there. All right. So now we are in better shape because we can complete the square. Step 2 now is complete the square. I'll keep my 2 out front. I'm going to leave a blank spot. This is also a part that changes a little bit. But again, half of 5 is, we did this in the last problem, half of 5 is 2.5. And 2.5 squared, meaning 2.5 times 2.5, is 6.25. Now, this is the second place where it's a little bit different. It looks like I added 6.25. However, I want you to notice that everything in these parentheses is being distributed to. This 2 came from them, so technically it belongs back with them. That being said, I actually didn't only add 6.25. That 6.25 is being multiplied by 2. So I added actually 6.25 times 2 on the inside. So on the outside, I'm going to subtract 6.25 times 2. Again, because of this 2 up front. All right. Final step is to factor and simplify. Keep my 2 up front. This becomes x plus 2.5 squared again. This becomes this. And then negative 3 minus 6.25 times 2. Well, negative 6.25 times 2 is negative 12.5. I'm just using a calculator for this. I happen to remember it in my head. And then I have this negative 3 that it's supposed to be combining with right here. In total, this gives me negative 15.25. So minus 15.25 is what comes down here. And now we are once again in vertex form. So this is kind of a rundown of what we learned. Real quick, the vertex of this comes from h comma k. H is the opposite of what we see in the parentheses. K is from exactly what we see at the end. And my axis of symmetry comes from x equals h. And again, h is always the x coordinate of my vertex. So x is negative 2.5. All right, if you have other questions, please feel free to email me. Otherwise, I hope this is helpful.